Hello and welcome to the first video on our Introduction to Statistics course. This will just be a basic introduction of what to expect in the course, talking a little bit about statistics and setting us up to start the course proper in the next session. So when we think of statistics, we have two main goals, and I'll just write some notes here as we go. Main goals. First one certainly is to describe information effectively. We have some data that we collected in some way, and we want to present that in a way that conveys information effectively. So we'll certainly start with this first goal in the upcoming sessions, but there's also another, perhaps you could say more important goal, and that is that we want to effectively analyze the data that we collected to make informed decisions in the future. So both of these is to make future decisions. Collect information because we want to use that information to be more prepared for a similar decision or question or problem that could come up. So with this goal in mind, we have what is called evidence. I'll keep my writing as neat as I possibly can. Evidence-based practice. And all that means is that we want to not say, well, I feel that this medication is going to be effective for patients to cure a certain illness, for example. I feel that this treatment can help some people. No, we want to base our decision of how to proceed, what treatment to use, what medication. We want to base that on previous evidence, where we have a test group where we test the medication, we test the treatment, and based on that, with our statistical methods, which we'll introduce in this course, we want to describe the information that we find, the results. We want to analyze those results so that we can then say, well, based on this evidence, this is an effective treatment. Doesn't mean it's going to be with every specific case, but we have evidence to back our decisions that we make in the future. So we want to use data from actual real studies done, real research that we can say, well, we don't know exactly if a treatment will work for an individual, but we have evidence, we have an actual research paper that we can base this on, where someone has shown that this can be successful. Because we want to make the best decisions, make the best future decisions. Now, there could be a case where we've never treated this illness, right? Then it still makes sense through evidence-based practice to conduct a smaller study, conduct some research first, instead of just saying, we're going to give this a shot, see what happens. Maybe it cures some people, maybe it doesn't. No, we need to base our decisions on sound logical practices, make the best future decisions that is possible. There's always uncertainty, and that's really why the subject of statistics exists, but we make the best decisions we can. And these studies can't just be wishy-washy studies, right? They have to be peer-reviewed, rigorous studies, rigorous, where the methods involved are explained. They can be duplicated, procedures, they can be viewed. So the methods involved have to be rigorous and carefully explained, carefully conducted, unbiased. And we are always hoping for what we call a large effect size. Now, we're going to refer to effect size later on, but very loosely speaking, it just is a way to indicate how significant and valuable the results are, very loosely speaking. And we also want to find that we're looking for practically significant results. Now, we're not going to spend a lot of time on this. I'll just mention it as we go. But there is a difference between statistical significance and practical significance. And we want to keep those things in mind. For example, if I test a new medication and we find that, yes, it does have a positive effect, that effect could be so small, yet still positive. It might not justify spending millions of dollars to implement this on a wide scale use. So there is a little difference between statistically significant, which we will focus on because it is on statistics, but it doesn't always mean practically significant because practically speaking, there are other factors. So we have some keywords that I want to mention as early as I can, which is right now. In our discussion on statistics, we are going to talk about a variable or variables. And that is just, loosely speaking, the property or characteristic that we are investigating. It's hard to speak and write something different. Characteristic or property or whatever we are studying. So the characteristic being studied. That could be maybe people's weight. How does a certain exercise regime affect people's weight? So the variable is weight. And then this variable can have many different values. Possible, say loosely speaking, results that I can get when I measure a person's weight. Numbers, but it doesn't always have to be. Possible results that the variable can have. And then when I actually want to conduct my study, I'm going to have actual people, not everyone, because it's impossible to measure the variable for every single person. I'll only have some people, maybe hundreds, but still not absolutely everyone. And the values that I get from those specific people are called scores. Score. Let's maybe make them all singular here. So the variable that I measure, well, no, it can be a single variable that I'm measuring, a single characteristic, the weight of people. but I can have many different values. And when I have my actual group that I'm measuring, I get their specific values, and that's called scores. So that we can tell the difference between, are we talking about the variable in general, or are we talking about specific measurements that we have done? So the actual values from a particular, let's say, particular measurement or study that we read about, or maybe we conduct the study ourselves. So the variable is, what is the variable? What are we studying? What are possible values? What scores did we actually get? See if I have space here, but I don't have that much space. I'm going to make a new page. Bear with me. That's going to be a lot. And I screen as best we can. So in general, we have, whoops, that's a Y. Ooh, brilliant writing. You'll get used to that too. But I think it's more fun than showing slides that were hands. I write it with you. We have different types of variables. Now, we're not going to make that big a deal of it, but the types of variables can be split into two basic groups in the way I see it. We have numerical versus categorical, and these have different names as well, just to confuse you further depending on which book you may look at. We can have a variable like weight, height, something that is measured by way of a number. Or we can have a variable like ethnicity or gender, regardless of how many different classifications you may have in the study. It's not a number, right? It is different categories. So we have variables, that can't be measured in numbers, but more in categories, by name. So we have this other type of variable. And only towards the end of the course are we going to be ready to really analyze a categorical variable. For the vast majority of the course, because it's our introduction and it is easier to get a handle on the statistical concepts, we are going to mainly focus on numerical variables. Within this, unfortunately, there are subtypes as well. Now, really, I don't want you to be confused between interval variable or whatever variation of name and a ratio variable. I'll just briefly mention here. Interval variable, you can think of height or weight, something where an increase of 1, for example, means the same regardless of how big or small the number is. Like if I am 1 inch taller than someone else, but I'm only like 5 feet, or if someone is 7 feet tall, 1 inch taller still means the same thing. A ratio variable, still numerical. Think of it like temperature, where it has a 0, where a height of 0 among people is not really meaningful, right? How can I get a height of 0? But I can get a temperature of 0. So I have this 0 reference. But in all honesty, in our introduction, for the most part, it's not something you have to really worry about differentiating between these two. There is a third one, though, Some people call them a rank variable, a rank order variable. Some use variable. Something like if I conduct a race in my experiment and I see the positions, then there's a first, second, third, fourth, and so on. Those are numbers, but they are a little bit different than measurements because when I measure the height of someone, I can get a wide variety of numbers, right? But when I measure race positions, I'll always get first, second, third, fourth. I'm never going to miss one of those. Maybe there's a tie, but in general, I'm not going to miss any of the positions. The ordinal variable is not the same as the other two. These are the most common. Spend most of our time. There are statistical tests and ways to analyze information that changes depending on the type of variable. How I handle race positions is not going to be the same as handling height measurements. Or you could think of a categorical variable maybe as hair color, where I can maybe measure color. That's really not the point here. I'm going to have classifications of color in a basic sense: brown, blonde, black, red, and so on. How I handle this variable is going to be quite different from a numerical variable. But even though I want to be aware of it, it's not something we can really talk about from the beginning. We want to, in our introduction, spend time with our basic numerical variables that in my mind really can be grouped into one. Numbers, just numbers. Fancy, nothing strange. To get the idea of what statistics is about, and then towards the end, we can say, okay, now that we have the idea stays the same, but how do we modify things to handle a categorical variable, an ordinal variable? Have that foundation before we make things more complicated. Simplest cases are just numbers like height, weight, temperature, things like that. So don't obsess about types of variables in the beginning. Try and get the idea of the concept behind statistical analysis. And that concept transfers into the other more complications as well. Right, so let me talk about how I'm going to structure this course. Other people can do other things. This is my course. This is how I'm going to do it. There's a lot of things that we need to address. I'm going to break it up into 12 topics. Some are going to be very different from each other. Some are not going to be that different, but I don't want too many. 12 is a nice number I can get on top of. But within each topic, we're going to have subtopics A, B, and C. It's going to be easy to remember. A, B, and C. Mean. So as we talk about each topic, that specific topic is going to be broken up into 3 pieces. First, I have to start by acquiring the knowledge of what that topic is about. And I want to understand the concepts. We're going to have a little discussion, sometimes short, sometimes a little longer, depending on the complexity of what the topic is about. Building up our introduction to statistics systematically. So most of these topics, one will build on the previous ones, build our foundation of understanding. But as I understand each topic, there's a lot of calculations involved in statistics. You can't get away from it. Whether someone else does it or whether you do it directly, it has to be done. I have to understand how that is done. So B is going to stand for battling calculators, but we're going to make it as easy as we can. We're going to break this calculation part up into a few pieces, and we're going by hand because you really understand something if you can break it down and do it by hand yourself. We're going to see how spreadsheets can be used in a basic way, make that calculation user friendly and just an easier time, less frustrating. And then we also want to see something a little bit more practically relevant, realistic, and how dedicated statistics software can be used for calculations on much larger data sets. So we don't want to jump, in my opinion, I don't want to jump to software handling everything because then I don't really know. I just hope it does what I hope it does correctly. I don't really know what it does. So I want to do things by hand. And of course, those examples will be smaller. I'm going to use a spreadsheet. Not going to be too attached to Microsoft Excel, but that's what I will use. But I'll use it in a way where you can use OpenOffice well. And then the software I'm going to use is SPSS to handle larger, more realistic situations. But calculations that I have comfortable with. And then perhaps as a little afterthought, but still quite important, C is going to stand for citing. I just want to end each topic by noting how things are presented, how things are discussed in the literature. Studies that have already been done, reports that have already been written, papers, articles, prior research. When is information presented effectively? When is it not presented effectively? Fall into a couple of categories in your career. You might be someone that is conducting your experiment, doing the analysis, setting up the study and everything, doing the calculations yourself. So then B is, of course, super important. C is important because you have to write the paper. You have to write the results and present it to someone else, and you want to do that effectively. But on the other hand, you could also be someone that just needs to understand what they're reading to be able to make sound evidence-based practice decisions. Research has been done, but you have to understand what calculations have been done and what results are coming from that. You might not be the one doing them, but you have to interpret the result. So regardless of whether you're writing or reading, we want to just have a short discussion, short mention, really. It's not even a discussion of what to look out for in written versions of it. Some of it's good, some of it's not so good in effectively conveying information. There are 3 books that I'm going to use in constructing the contents of all excellent books. Buy them if you want to, up to you. First one, statistical psychology. Just, in my opinion, just a wonderful book. Explain, uh, break down the steps involved in analysis, just very good. We might also reference statistics and data analysis for nursing research. Also, an excellent book, and it has very good references to how to use SPSS especially. And in terms of C part, I might reference reading statistics and research. There are many versions of this, but this book mainly focuses not specific calculations, but a little bit broad. When things are done effectively and less effectively in the what to look out for when I write it myself, or how to read and interpret that have already been written. Right. So that uh, is our introduction to this course. I hope you enjoy it. I hope you find it valuable and interesting. Questions next time. Thank you.